Good morning, class. We are looking at pre-calculus practice test number 5, module 5, chapters 9 and 10. Review, here's chapter 10, analytic geometry. So we start with chapter 10. We want to find an equation of the circle, which has the center at 1, -2, radius of 2. We want to graph the circle. So with that being the case, first, let's remind everybody what is a circle. A circle is the set of points in a plane that are the same distance, called the radius, from a fixed point called the center, looking like that. If it's centered at the origin or 0, 0, the formula is x squared plus y squared equals r squared. That's a standard form. If it has a different center, such as h, comma k, then the standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. So we have all the information here, and also, of course, area is pi r squared, circumference is 2 pi r. I don't believe anybody has any problem with that. Everybody remembers all of it. So we have the radius, we have the center, and we are going to put it into this equation. X minus h, that means x minus 1 quantity squared, plus y minus k, that means y minus -2, which makes it +2 quantity squared, equals r squared, 2 squared, which is 4. So basically, this information goes into this equation, and that is the equation. Now, we start from the center, located at 1, -2, and since the radius is 2, we go 2 units to all sides, right, left, up, and down. So if we go left and right from this point, we get to these 2 points. Just simply put add 2 and subtract 2 from the x coordinate of the center. Now add 2 and subtract 2 from the y coordinate, up and down. There you have it, and put them all together. That would be a good practice for graphing it by hand. Now we want to write the equation of this one in standard form, and to do so, we have to put it in this format, which means we got to come up with the center as well as the radius, and this requires the use of completing the square. Therefore, we put these two together, and we move the constant. Now, I hope you remember this is b. -4, you divide it by 2, becomes -2, and you square it, becomes a +4. So you add +4 to both sides. And this one is b. 10 divided by 2, 5, squared is 25. So we are going to add 4 to both sides for the first parentheses, 25 to both sides for the second one. Well, we are practically there. Here's the center, 2, -5. Here's the radius, square root of 36, which is number 6. So from the center, we're going to go r units, 6 units to the right and left, up and down, resulting in this 4 pairs. So we have the center, 6 units to the right. That means 6 and 2 is 8, this one. 6 units to the left, that means 2 minus 6 gives you this one. Now up and down, so add, look at the y coordinate, add r units up and r units down, that means 6 units, giving us those 2, and we have the graph. We want to graph the ellipse by finding its center and vertices, x squared over 25 plus y squared over 16 equals 1. Could you read this, please?
An ellipse is a set of points in a plane, the sum of whose distance from two fixed points is a constant. The two fixed points are called the foci.
Foci, yes.
Each is a focus. Of the ellipse, F1 and F2 represent the two foci of an ellipsis. PF1 plus PF2 equals 2a.
Perfect. In other words, if we look at this one, the concept is if you pick any point such as P, connected to focus 1, F1, and focus 2, F2, this distance of a PF1 plus PF2 is fixed. Now, if I change that to a different location, it makes no difference. If I put it here now and connected, it is also fixed. Let's call it Q. So QF1 plus QF2. And if you put it here, by the way, which is called the vertex, as you can see, it is also fixed. And that is the proof that it's equal to 2a. The reason being the distance from here to here plus the distance from here to here. This distance is the same as this one, and it gives you from here to here, which is 2a. So if you pick this point, you can prove this. So with that being the case, if the center is located at 0, 0, it's x squared over a squared plus y squared over b squared equals 1. If it's at a different location, such as h and k, x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. The area is pi AB. A circle is a special case of an ellipse where A is equal to B equals R. So I repeat. Circle is a special case of an ellipse. What makes it special? A and B are identical, and we call it R. So we know the area is pi R squared, so it's pi AB. That's another way to look at the proof. Now, B squared plus C squared equals A squared. This is the focal distance from the center to F1 or F2, this distance. From the center to the vertex, it's A, and this is co-vertex, if you will, it's B. And if you put them together, it gives you a Pythagorean theorem, and you can easily prove that. The Pythagorean theorem is B squared plus C squared equals A squared. A is larger than B. However, if it's elongated along the y-axis and B is the largest one, then it's A squared plus C squared equals B squared. So please understand, it follows the Pythagorean theorem, and the largest one, depending upon whether it's elongated along the x-axis or the y-axis, changes. Okay, along the x-axis, A is the largest one. Along the y-axis, B is the largest one. So you want to pay attention to that. With that being the case, going back to this, the center is at 0, 0. A is square root of 25, which makes it 5. B is square root of 16, which makes it 4. Now that we have this, then we have, and this is larger. See, A is larger than B. So it's elongated along the x-axis with the vertices at 5, 0 and negative 5, 0. So here's the center. Okay. So one more time, here's the center. Here's the 2 points that are the vertices. And B is 4. We go 4 units up and down. And those are the co-vertices. And now put them together. Identify the coordinates of the center, the vertices, the co-vertices, and foci. We want to graph the ellipse also, and here's the equation. So as you can see, comparing to this one, obviously, we can see it's centered at -5, +7, compared to this one. In other words, set x plus 5 equal to 0, that gives you -5. Set this one equal to 0, gives you +7. So -5, +7. A is the square root of this number, which makes it 2. B is the square root of this number, which makes it 3. So right away, you notice B is larger than A. So that means it's elongated along the y-axis. So with the center being at -5, 7, we go 2 units to the right and left and 3 units up and down, and we write all of them because 3 is larger than 2. Up and down becomes the vertices. So here's the center -5, 7. Up and down. Okay, we got it. And then from the center, 2 units to the right and left. Again, I hope you see that when we say 2 units to the right and left, that means look at the x coordinate and add and subtract 2. That's how you come up with that. And we want to calculate the location of foci. We need to go with this formula. Now, in this case, depending upon which one is largest, remember, it follows the Pythagorean theorem. As you can see, B is the largest. Therefore, A and B will interchange in this case. So it's important for everybody to know it follows Pythagorean theorem, but the largest one is on the right side in essence. So with that being the case, A squared plus C squared equals B squared, where A is a 2 quantity squared. So if we were to write that, 2 squared, which is 4, plus C squared, which is missing, equals B squared, which is 9, or let's just write 3 squared. And therefore, C squared is 9 minus 4, or 5. C becomes square root of 5. Now, it's important for everybody to understand, again, we are talking about elongated along the y-axis. So those are the vertices, and therefore the foci are also along that. So you look at the center with the coordinates that you have, you calculated the value of C, you go up and down by C units, up and down by C units. So 7 minus square root of 5. This is precise. We use a rough estimate for the sake of, graphing and plotting. And if we add square root of 5, we get 9.24. And so those are the 2 pairs. And this is the graph of this ellipse. Now, the graph is given, and we want to come up with the equation in standard form, and we can use either this one or that one. We can clearly see the center is not located at 0, 0. That means we have to use that one. So let's locate the center. Clearly, the center is located at -2, 2. So we have that. Let's look at the vertices. And as you can see, again, elongated along the y-axis. So this distance is larger than this distance. This is the distance of A. This is the distance of B, okay? So my apologies. This is B. This is A. A A is 2 units. From here to here is 2 units. From here to here is 3 units. So A is 2, B is 3. A is 2, B is 3. With the vertices being located at -2, 5, -2, -1. Again, let's just actually do this. So this distance is A. Let's use a different color. This distance is B. Those are the co-vertices, by the way. We have the locations -4, 2, 0, 2. We read it from the graph. So we have A, we have B, and we have the center. So we're going to put it into this equation. X minus h quantity squared over A squared plus y minus k quantity squared over B squared. So x minus -2, that means x plus 2 over 2 squared, which is 4, plus y minus k quantity squared, that means y minus 2 quantity squared over B squared, which is 3 squared equals 9. And that becomes 1. So this is how you arrive at the equation. Given the equation of the asymptotes, give the equation of the asymptotes and graph the hyperbolas. Those are hyperbolas. So let's look at the definition. Could you please read this?
Hyperbolas. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points, called the foci, and is a constant. PF1 minus PF2 equals 2a.
Perfect. So when we look at the hyperbolas, they also have a definition, just as we defined other conic sections, a circle as well as an ellipse. So now if you pick a point such as P and connect it to the foci, focus 1, focus 2. So let's say this is F2. Now PF1 minus PF2 is fixed. PF1 minus PF2 is fixed. So the distance between the two is fixed. When you look at the hyperbola, it depends whether it opens sideways or up and down. If it opens sideways, has the formula x squared over a squared minus y squared over b squared equals 1, where this distance is a and this distance is b. Now, if it opens up and down, I like to keep the b under the y. Some texts, they do change that, and I'll tell you why I don't in a moment. If you keep them intact, in other words, the b is always under y, or the b squared is under y squared in essence, then the formula for the asymptote doesn't change. It's always y equals plus minus b over a times x, and I like to keep it that way. So in both cases, if you look at these two cases, the center is at 0, 0. And the equation of asymptotes is y equals plus minus b over a times x. So this is the same for both of them. In this case, we have it open sideways, okay? And the vertices take place at a0 and negative a0. But if we happen to have it in this format, then it'll look like that. This is for this case. And again, I want to keep the b squared under y squared, so everything is the same. What changes in this case? It opens up and down, in which case the vertices are at 0, b, 0, negative b. And again, this is fixed at 2a because if this is true for any point, I can pick this point and connect them. Let me just actually pick another point just to make a point. If I pick, let's say, this point and connect those two, and I call this Q, then QF1 minus QF2 is fixed. So all you have to do, just pick up this particular point. Let me use a color that will, if you pick this point and now calculate the distance, you see that this is a proof that it is equal to 2a. That proves the formula that the distance is 2a. All right, having said that, let's look at both of them at the same time for a couple of things. Number one, both of them have center at 0, 0. This one a is 4, square root of 16. This one b is 5, square root of 25, and they have the same answer so far. So this is the same, the center a and b. Now let's go and stick with part A. In the case of part A, we have different vertices. This one is like the blue one here, open sideways with the A of 4, B of 5. So this location is 4, 0, and this location is minus A or minus 4, 0. So we can also calculate the asymptotes plus minus b over a times x, which is identical for both cases. So let's take a look at what happens. For this one, here's the vertices. And for both of them, here's the asymptotes, plus minus b over a, 5 over 4, x. And we graph those. And so far, they look identical. But in this case, the vertices are located here at 4, 0, minus 4, 0. And the graph looks like that. And let me put back the asymptotes. The asymptotes are always dashed lines. For the second case, everything is the same. By that, I mean the center is the same. A and B are the same. Asymptotes are the same. The only difference is the vertices are not the same because notice y squared has a positive coefficient in essence. In fact, you can set x equal to 0 to see what happens, y equal to 0 to see what happens. And you'll notice that one of them doesn't give you a solution. I highly recommend you do that. So in both cases, set x equal to 0, find y, set y equal 0, find x, and see which one works. And the one that doesn't work is out. The one that works, those are the vertices. In this case, the vertices are located at 0, 5. 0, negative 5. So those are the vertices. And let's also throw in the asymptotes. Pay attention again to the fact that the asymptotes are dashed lines. I can't emphasize this enough. Could you please read this?
Identify the coordinates of the center, the vertices, the foci, and the equation of the asymptotes. Graph the hyperbola.
Perfect. So we are looking at the hyperbola, which has a different center now. Okay. So comparison, we can see the center is located at 1, 2. A is the square root of 9, which is 3. B is the square root of 16, which is 4. Again, this is the standard form with a different center, centered not at the origin. So that's the first thing. Center, A equals 3, B equals 4. And because this thing is positive, in other words, the coefficient of x, or in this case, x minus 1 quantity squared is positive, then it opens sideways. That's the idea. So let's see what we have. The asymptotes follow this formula. Y minus k equals plus minus b over a times x minus h. So when we plug in y minus 2. So in other words, it's the same as this one, plus minus b over a 4/3, and just like this one, x minus 1. Now, all you have to do, just pick up a pair. Please understand this means two equations. Let me write it and then I erase it. I want to make sure everybody understands that we are dealing with two equations here. This one, and I need this, maybe if I can make it happen here. One of them is y equals, if we take the 2 to the other side, is a 2 minus 4/3 times x minus 1, and you can simplify it. The other one is 2 plus 4/3 times x minus 1. And remember, to graph it, just pick up a couple of pairs. X is 0, find y, y is 0, find x. The same thing for this one. When we do that, okay, so this is the case, and there are the two equations, and you can multiply the minus 4/3 or positive 4/3 and write it in slope-intercept form. So when you finish the job, those are the pairs. This is the pair for the first, and this is for the second one, and they can give you the two lines. This is as far as drawing the asymptotes. So you can see the two asymptotes. This is 1 point. This is, which is 0, 10/3. This is 5/2, 0. And this one is 0, 2/3. This is negative 1/2, 0. So you have the asymptotes. So you have the asymptotes and you have the center. So we have the asymptotes, we have the center. And we know it opens sideways. All we have to do, A is 3 units. So go to the center, 3 units to the right, 3 units to the left. So A equals 3 units to the right and left of the center. So from the center, we want to go 3 units to the right. That means add 3 to 1. And we want to go to the left. That means subtract 3 from 1. So we have these two pairs by going to the center and add and subtract A. This is the distance of A, everybody. Let's just write it in case. Okay. All right, so we got the vertices. And the next thing is to find the foci as well. So focus 1 and focus 2. So in the case of finding foci for hyperbolas, this formula, Pythagorean theorem, works too. And it's a squared plus b squared equals c squared. C is always larger than both of them. And therefore, the equation will never change. That's the beauty of this case. In the case of a hyperbola, this equation doesn't change. C is always larger than A, larger than B. So 3 squared plus 4 squared equals c squared. And if we plug in 9 and 16 is 25, C becomes 5, and the center is at 1, 2. The center hasn't changed, right? So again, it's sideways, so we are going to go C equals 5 units to the right and left of this number. So the x coordinate is 1, add C units, that means 5 units, becomes 6, and subtract 5 units becomes 1 minus 5 or negative 4. Same y coordinates. So those are the foci. So I hope everybody can see how easily we can calculate those. And here's the graph. Let's throw in the asymptotes, and as always in dashed format. Use the graph of the hyperbola to determine its equation in standard form. So here's the graph. By the way, those are the asymptotes that they don't have. The asymptote goes through the center. So we have the center. We write it down, -1, 0. And as long as we have the center, okay, if we look at this equation, we have the center. So what is missing and we needed is A and B. So the center is located at -1, 0. All we have to do, find A and B. And we notice that it opens up and down. So you need this distance. And that is the value of B, by the way. So let's calculate this distance. From here to here. This is the value of B. And as you can see, we have the vertices and B becomes simply 3, the distance of 3. Okay, so we have B, we need A. How do we find A when it's not given? We notice the location of the first focus and the second focus. So foci are located at these 2 points. And so we can calculate the distance from here to here, which is 3 square root of 2. The distance from here to here. Let's see, what color do we use? So this distance is C. This distance. And we know A squared plus B squared equals C squared. We know this is 9. We know this is 9 times 2 equals 18, everybody. 3 squared is 9, square root of 2 squared is 2, their product is 18, subtract 9, you get 9, and A becomes 3. So A and B are both 3. Let's put it into this equation. And we end up with y squared over 9 minus x plus 1 quantity squared over 9 equals 1. We don't have to come up with the asymptotes, but it may not be a bad idea. The asymptotes, we use this formula. Remember K0, by the way. So y becomes plus minus the m plus minus x plus 1. And let's throw in the asymptotes. And you're done again. This was an ask, but I thought maybe it's worth it. Could you read this, please?
A parabola is a collection of all points P in the plane that are the same distance d from a fixed point F as they are from a fixed line D. The point F is called the focus of the parabola, and the line D is the
Directrix.
Okay, thank you. As a result, a parabola is the set of points P for which, do you want me to read that?
Sure, the distance of F and P is the same as the distance of P and D. In other words, however you draw this, it's important to know the meaning of it. If you pick any point, for example, P, and connect it to the focus, giving you the distance PF, it is identical to the distance it makes with a line called directrix. And directrix is always perpendicular to the axis of symmetry. Perpendicular to the axis of symmetry. That is the definition. That's how they do the drawing. So this distance, PF, is equal to PD. That's important to understand. Now, I want to go back to intermediate algebra, and I want to remind you, this is what we learned, and we can go back and forth. And even if you want to stick with that, and then just a slight change, you can go from this format to the format they want you in this course. That's fine. Just pay attention to what we learned in intermediate algebra. Y equals ax squared plus bx plus c, or a times x minus h quantity squared plus k, centered at h and k. This opens up or down, depending on the value of a. X equals ay squared plus by plus c, or a times y minus k plus h. This opens right or side depending on the value of a. If a is positive, up and negative down. If a is positive here, to the right. If negative, to the left. And I believe most everybody remembers that. You can stick with that. Now they make these changes. I want you to see basically what the relationship is between these two and the one we have here. The only thing that you really need to know is the relationship between A and P. This distance that we call it P, some texts they call it A, some texts they even call it F. It's the focal distance. So P represents this distance. Which is, by the way, the same as this distance. And I hope you realize why they must be the same, because of this definition. If the point you pick is here, then the distance from here to the focal point and to the directrix, they must be identical. These two distances are the same, and they are called P. So A equals 1 over 4P, or P equals 1 over 4A. Let me just write that also, because that might be handy. Or you might say P equals 1 over 4A. And if you're comfortable with this, stick with that. And if you finish the job looking like that, and somebody says, okay, what is the focal distance? Remember, P is 1 over 4A. And that's a relationship. That's all you need to remember. Now let's look at the case in general and how they work. First, I want to stick with the opening up and down, because we had done that first when we did intermediate algebra. When it opens up, okay, we have a vertical line of axis of symmetry. Okay. Now, if it opens up, remember the focus is somewhere inside. So wherever the vertex is, you have to go up, which means the x coordinate doesn't change. You go up by p units, and that gives you the focus. You go down by p units and write the equation, which is in this case, y equals a number. So please understand, the directrix and the axis of symmetry, they are perpendicular. D is perpendicular to the axis of symmetry. And axis of symmetry, I hope you remember, when we had it in this format, x equals the x coordinate of the vertex, which was, if you have it in this format, x equals minus b over 2a. If you have it in this format, x equals h. If you have it in this format, y equals k. So I'm reminding you everything that we have seen before. So opens up, you calculate the distance of p, you go up for the focus, down for the directrix. If it opens down, the other way around. So you don't have to memorize all of this, because sometimes they explain things, they give you the formula such as y squared, over here, x squared equals 4ay, over here, x squared is minus 4ay, so on and so forth. You can stick with what we learned here. Now, if it opens sideways, after you know it opens sideways and you have the vertex, so the focal distance to the right, that would be f, okay, so go to the right, and to the left of it, that would be the directrix. If it opens to the left, it's the other way around. We also have this definition, lattice rectum. The lattice rectum of a conic section is the chord through a focus parallel to the conic section directrix, and it's equal to 4p. So take a look. This is called lattice rectum, and the distance from here to here is 4 times p. And the reason why is very simple. If you pick this point has the same distance to F and to D. Remember, this distance is the same as this distance times 2, okay? And it's the same as this one. So this becomes 2p, this becomes 2p, and they add up to 4p, in case anybody is interested in the proof of that. So again, it's important to have the shape in mind and then make a decision how we go by finishing the job. I'm going to show you with a couple of examples. Could you read this question, please?
Identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equations of the axis of symmetry and the directrix. Graph the parabola.
Perfect. If this is confusing, just go to write it in this format. Just go with the first format. That's absolutely fine. And speaking of the first format, if x has degree 2, it opens up or down. If y has degree 2, it opens sideways, right or left. So just by looking at this, y has exponent 2, so it opens sideways. And a is positive in essence. You can solve for that if you want. The location of the vertex x plus 4 equal to 0 makes this negative 4, y minus 2 equal to 0 makes this 2. So the vertex is located at negative 4, positive 2, and it opens to the right. You don't see any negative number. If you have a negative number here or here, doesn't matter which way, then it opens to the left. So the first thing is, because y has degree 2, it opens sideways. So if it opens to the right, you can locate the vertex is here. Now, before we continue, to make life easy, it looks something like this. This is not to scale, and I'm going to erase it in a moment. It look something like this because we know it opens to the right. Why am I drawing this? Because I know my focus is somewhere here. And again, this is not to scale. I know through the vertex is my axis of symmetry. I'm going to call it short for axis. And I know this line is called the directrix, is perpendicular to the axis of symmetry. And I also know this distance is the focal distance, and this distance is the focal distance. So my suggestion is, if you come across a question like that, have a rough sketch, and therefore you can come up with the rest of it. Okay, so you expect the graph look something like that. That's the idea. Okay, let's erase all of it. And take it from there. So you already have an idea how it looks like. So let's calculate the focal distance. And remember, a equals 1 over 4p. Or 4p, in this case, if you compare it to this equations that you have here. 4p is 4 over 5, p is 1 over 5 or 0.2. Or as I mentioned, you can even write it in this format. If you feel more comfortable with this format, it's absolutely fine. So in essence, you're using this. So with that being the case, we have the value of a p, and if we want to calculate the focus, remember, look at the center, look at the vertex, and we're going to go to the right by this much. So to move this to the right by this much, that means add this number to the x coordinate. Now, the axis of symmetry, as I said, it's clear. This is the axis of symmetry. Y equals 2. So that's the focus. That's the axis of symmetry. Now, we want the directrix, which is perpendicular to that. And let's go back to the vertex. And we said it's going to go behind that on the left side. So we're going to go to the left by this much, which means we're going to subtract this number, whatever that one is. Okay. And we come up with the answer. We're going to subtract this from the x coordinate, which is -4, minus this number. And therefore, x equals, x equals -4.2 is the directrix. Put them all together. You have the graph. So a quick recap, as far as, the last one is the lattice rectum, and by definition is 4 times p. Lattice rectum is 4p. We already have that. This is the answer. This is the lattice rectum. Again, the definition, the lattice rectum of a conic section is the chord through a focus parallel to the conic section directrix for a p, which is 4/5 over 0.8. Either one is fine. Use the graph of a parabola to determine its equation in standard form. And I want to look at this both ways, the way we approach it in this course and also intermediate algebra. I'll go over both of them just to remind everybody what we have. So when we look at the graph, it opens down. So right away, it is x has a degree 2. So if we stick with this one, it's this format or this format with this center, and it opens down, so a must be negative if we stick with that format. If we stick with this format, okay, x squared equals 4py, and we write down x minus h quantity squared is minus 4py minus k. I hope you see that this ultimately becomes this one in essence. So if I take this one to the other side, becomes 1 over 4p, and then I add the k. So let me actually show that to you, so how that works. If I take those steps, I can say I'm going to get rid of this. So I'm going to write 1 minus 4p times x minus h squared equals y minus k. Now I'm going to move this, and I get minus 1 over 4p x minus h quantity squared plus k equals y. This negative is because it opens down, class. I hope you see that they are identical. So you see how we arrive at it. And this is the value of a that was discussed. So either way, I suggest you stick with the method that you're comfortable with. You can even stick with that and put it in the format they asked you. So let me erase that. And now the vertex is clearly located at -3, 5. The focus is clearly located at -3, 319/64, I believe. Okay. So sticking with that, notice we have the center. We're almost done. We just need the P. And what is P? Is this focal distance. P is this distance, everybody. The distance from the vertex to the focus. So that means you subtract this number from 5, the y coordinate of the vertex. So 5 minus 319/64 gives us 1/64. So that is the p-value. Plug in. And here's the final answer. I like to look at the same question from the point of view of what we had seen before and see how fast you can come up with the answer. Same thing, not a big deal, if we were to stick with that. All right, we already have the vertex, and we're going to use, we know that it opens up or down, in this case down, so it's going to use this formula. So we're going to use that formula, and we're going to plug in the vertex. Everything is done. The only thing missing is A. Well, we know A is what? 1/4P. And what is P? We already have it. Of course, P in an absolute value sense is that because it opens down, you can say 1 divided by that. And then because you know it opens down, make it negative, or just simply 1/-4P. Either way is fine. And if you replace the A, you get this answer. And I hope you see that you can go from this format to this format, or from this format to this format. This is the one that we learned in intermediate algebra. If you move the 5, you get y minus 5. And if you move the -16, that means you're going to divide by it, you get -1/16. That's how they do that. So that's as far as finding the equation in standard form is concerned. Given the function expressed in standard form, f of x equals a times x minus h quantity squared plus k in this format, and find the x-intercept, the y-intercept, the vertex, the axis of symmetry, and the whole enchilada, basically. So here's the function f of x equals 2x squared plus 4x plus 6. And what we can do, there are two ways to find the vertex. It's one of them is x equals minus b over 2a, or you do it by the method of completing the square. Let me quickly show you both ways. If I want to complete this square, I put these two together and take the 2 out. This one is b, half of it is 1, square it is again 1. So when you add 1 inside the parentheses, you're adding 2 times 1. So you either have to add 2 to the other side or subtract it from the same side. I hope you understand 2 times 1. We are not adding 1, we are adding 2 times 1. So we subtract 2 times 1 on the same side, or we add 2 to the other. However you want to do it, and then bring it to the same side. And so when we put it in this format, we can see the vertex is -1, 4, a is 2, which means opens up. Here's the vertex, and we know it opens up. Now, before we continue, we could have done it this way. The x coordinate is minus b, which is 4, 2 times a, which makes it 4 with a negative in front, makes it -1. We could have done it that way. And then plug in -1 into this, and it gives you 4. I just wanted you to be exposed to both methods again, reminding you how we did that. Now, so let's plug in the vertex. Going back to this, we need the intercepts. X is 0, that means 0, 6, and Y is 0. There is no x-intercept. Why is that the case? If you set this equal to 0 and you calculate the b squared minus 4ac, it becomes negative. So there is no x-intercept. I'm reminding you of something we learned in algebra. Let me just quickly show you. So if I write y or f of x equal to 0 to x squared plus 4x plus 6 equal to 0. If you calculate the b squared minus 4ac, which is 4 squared minus 4 times 2 times c, that is a negative value, which means there are no real solutions. That's why you don't have that. All right, we know the axis of symmetry. So that's the point, 0, 6, okay? The y-intercept, there's no x-intercept. Axis of symmetry, x equals -1. And we also have this point -2, 6 because of the axis of symmetry. Think about it. So the axis of symmetry is this one. And whatever this distance is, which happen to be 2, if you go further on the left, okay, which happen to be 1, okay, it's 1. Then we go 1 more to the left, it has the same 1 coordinate. And we know it opens up. If this is good enough, so be it. If not, you can always pick up more points. So that's the graph. Remember, this is the vertex. By the way, as far as the vertex in calculus, for example, normally we draw it like this, which means it cannot cross that. The graph cannot cross that. So that's the graph in this case. Identify the graph of each equation, in essence, each conic. The way it works, if you want to prove what type of a conic you have to put it in the standard form. However, if you want to answer it pretty fast, here's how it works. If x squared and y squared are both having exponent 2, then it's either a circle, ellipse, or a hyperbola. How do you know which one? When x squared and y squared, they are both on the same side. If they have identical coefficients, that's a circle. In this case, this is a circle. When they are on the same side, they have different coefficients, but they are both having the same sign. That means both positive or negative. That's an ellipse. If you bring it to the same side and they have opposite signs, that's a hyperbola. In other words, these two are identical. These two, this is number 1. It's not. And this is 9x squared minus 16y squared. They are opposites. That's why. Now, if one of them has a degree 2, then it's some sort of a parabola. If x is of degree 2, it opens up or down. If y is of degree 2, it opens sideways. So when we look at this one, x has degree 2, it opens up or down. This is negative, makes it opening down. Again, x has degree 2, up or down. A is positive 1, so opens up. Y has degree 2, so opens to the right or left. A is 1 or positive, and it opens to the right. So this is down. Degree of x is 2 and a is negative. This one is up because this is 2, a is 1. And this one is to the right because y has degree 2 and a is 1.